All right, so the both sections that we're doing today. Are similar to the circle thing. Did you all find doing the circles all right?
Yeah.
Now, this is my judgy face.
I did 12.1, 2, and 3 last night.
12.3 was circles.
Oh, that was midpoint, but it wasn't.
12.1 was midpoint. 12.2 and 12. There should have been circles on there.
Maybe I did a different one.
Well, if it's 12.1, 2, and 3, all one assignment, did you just not finish it?
I finished it, maybe I worked on the other one, there's 3 assignments, I did one of the 3 of us.
If you don't remember, did anyone else do 12.1, 2, and 3? Do you remember circles on it?
Yeah, there's circles and then there's midpoint and there's a parabola.
Parabola is 12.2, circles is 12.3, midpoint was 12.1. It should have had all of those.
Oh, I did 13, that's all.
Oh. Well, do you remember lecture from circles?
Yeah.
And was it all right? It's all right. So let's touch there real quick. As a reminder, oh, I gotta go through my spiel. Are we on the big day 20?
Yeah.
Gosh, that means we're running out of time, folks. Let's recap circles. X squared plus y squared equals r squared is a circle centered at 0, 0. With a radius of r. And when we adapted it to have a different location. The big change here is now the center is at HK. And to motivate this a little bit better, I'm going to do this in the main course, but I think it's helpful for you guys. If I divide everything by r squared, I get x minus h squared over r squared plus y minus k squared over r squared equals 1. Still a circle centered at HK. Radius r. I just got it written in a different way. So written as is, then good thing to note is same denominator. I remember when we were graphing the circle, we went up, down, left, and right arc. When we were graphing it, and then we connected the points in the big circle. Is this familiar to anybody? Does it sound ring a bell? Everybody else sound familiar? It's like, I'm online for a reason. Don't ask me questions. Alright, so how does this change for an ellipse? An ellipse looks like this. This will be 12.4. An ellipse can be like this. Center at HK. And it goes right, I'm gonna use A. And when it goes down, I'm gonna use B. So ellipse is kind of like an oval. And what does the formula look like in general? We have the x minus h squared and we have the y minus k squared. Pictorially on the circle, we went right r. And below the x, we had r squared. On the ellipse, we go right a, so below the x, we have a squared. And on the circle below for y, we went up and down r from the center. On the ellipse, we go up and down b. So that's what gets squared and goes underneath there. So the big difference between, the only difference, in fact, in an equation wise, different denominators. And so this is the only clean form of it. Where I think not having the fractions with r squared for the circles looks better. I think my red equation up here looks better for a circle. I can't do that here. If I multiply through by a squared and b squared, I'm gonna have different coefficients. I can, but it's not as easy to see what's going on. So what we're gonna practice in here is taking equations that are not in these forms and writing them in these forms.
Well, it seems like the circles. We're using the distance formula, and for the ellipsis, we're using the midpoint formula. Right, that's just the way that's like set.
No,
Oh,
midpoint formula does not come up in this.
it just sort of.
The midpoint formula is x1 plus x2 over 2 and then y1 plus y2 over 2. This looks nothing like that. These two look almost like, if I divide by r squared, these two look, if a squared equal b squared, the ellipse would be a circle. That's the only difference. If one of these denominators match, this becomes a circle. All right, so a little bit of practice. Let's start with equations that are not in the right form and write them as the right form. So let's go with like x squared plus y squared minus 4x plus 6y minus 3 equals 0.
Are we getting an ellipse or a circle?
Well, that's a good question. It's kind of hard to tell at this point. I can tell you right now the way to identify the difference is if they have the same coefficients, they're gonna be a circle.
Okay.
If they have different coefficients, they're gonna be an ellipse. So we need to write this, since this is a circle, we need to turn this into x minus h squared plus y minus k squared equals r squared. That's the shape we're going for, because that's how we can easily tell where the circle is in its radius, right?
Yes. We move the -3 over the equal sign and change it to +3. And then we want to complete the square with each, rearrange the variables and then complete the square.
Yeah,
Each
that's what we're
variable.
gonna do. So we move the 3 over and we rearrange the variable, we're going to complete the square. The easiest way to do that is to rearrange the variables, put the x's next to each other. Gives ourselves a little bit of room to work. Remember, we cut this in half. And square it, and that goes in here. And whatever I do on the left, I'm gonna do on the right. I'll cut this in half,
Yes.
square it, that's a +9.
What was a helpful tip? What you were telling me earlier to find if you complete the square right is to use the FOIL method.
Oh yeah,
So,
we'll do that in a second. This becomes x minus 2 squared. And this is y plus 3 squared. And I guess I'll move the 16 up here. Now, let's just make sure that we got the right thing. If we work a little bit like going along with what he said, let's make sure we did the right steps. We can always multiply this out and make sure we got what we started with. Plus 13 equals 16. And I subtract 16. And I got what I started with. Which means my complete the square was correct. So what does that tell us about this circle?
The radius is 16. Is that squared, right? Yeah, 16 squared, which is 4.
Square root of 16 is 4.
Square root of 16. And our center is +2 x and -3y.
Does anyone else agree with Keith, or is he wrong?
Our radius cannot be negative. It can only be positive.
Right, and in this case it is. You're right, but when we take the square root of 16. That's good something to note. Square root of 16. technically 4 squared and -4 squared both equal 16. So like when we do x squared equals 16 and we take the square root, we get x equals plus or minus 4. But here radius is a distance. And distances are non-negative. I'd say positive, but you can have a distance of 0. Seems stupid because you just haven't moved, but it's technically valid, like how far something moved, it didn't move, it moved a distance of 0. Is that working for you, Lauren?
Why? Why do we have a 2 and a negative for this sign?
That's a great question. Because if we compare the two, this is x minus h squared and y minus k squared. So it needs to, one way of doing it is just remember it's the opposite sign. Another way to do it is set the inside equal to 0 and solve.
They're always gonna flip flop.
Yeah.
signs? Okay, no matter what, okay,
They'll always flip flop sign.
okay.
Kind of like they did with the parabola, when we did like the inside, when there's parentheses, it did the opposite sign. Okay, so that was doing a circle. Let's kick it up to what we're doing today, ellipse. You guys ready?
This. Born ready.
Let's start with some baby steps. Yeah. Now, work with the ellipses, notice we have different numbers in front of the x's and y's. So that's a red flag that this is not gonna be a circle. So for things that aren't circles, like the ellipses and the hyperbolas we're gonna do today, we want this side to equal 1. Should be 1 after the right side is in, or left side is in parentheses. As it is. So we're gonna divide by 100. This should usually work this way in ellipses, but and hyperbolas, you should always be able to take the bottom and divide by the coefficient. That gets me 25. So the x plus 3 squared is going to be over 25 when it simplifies. And this one, when I do, if I do 100 divided by 25. I get 4. So the y minus 2 squared is gonna be over 4. When all is said and done.
Center. Hold on,
So what's the center here?
I believe it's -3 and +2.
Does anyone else agree with that?
Um. I would-
You guys go with that? Yeah, that's what it is. We're not, I'm not gonna, like, we haven't graphed these yet. I haven't shown you how to graph them yet. They're not too bad. We're gonna do that in the main course. We're just gonna practice getting them in the right shape in here.
Well, I was gonna say, how to graph them is you just take the square root of both of them and you. For 5, that's 25, square root of 25 is 5, and the square root of 4 is 2, and you move 5 over to the left and 5 over to the right, and then you go up 2, and then you go down 2, which should give us that only.
Have you been working ahead?
Oh, no.
You haven't?
No, because then when I ask you a problem, I tell you I have trouble.
That is exactly what we do. The x's we move 5. I should have done that in blue to match that. The y's, we go up or down 2. And then it's not circular, but we want to make sure it's rounded. So it's a lot like doing a circle.
Yes.
I think that's why I've never presented it with the. Showing this and then this at the same time.
Yeah.
I think that's a beneficial approach, because you can kind of see right away what the difference is. Yeah, that's exactly what we do. Good job, Keith.
We'll either know focus, textures, verses.
We'll cover vertices and focus we're doing in 12.6. So we're just introducing shape, location, and like stuff. We're gonna do the axes today and the vertices, but focus, which is how you literally define a circle, or an ellipse, we'll cover on 12.6. Same with hyperbola. We'll cover the foci is plural for focus. We'll cover focuses. Foci on 12.6 next week.
Yeah, sure.
So let's kick this up a notch. Now, let me give you guys one to do on your own. Let's go with. Let me think. Fuck it. Let's do that.
Yeah, I think X minus 5.
Yeah, it's 5. Thank you. And once you do it, write down what the center will be. And you don't have to graph it, but how far left and right will go and how far up and down will go. Keith busting out the fucking hard version of the ellipse on the own without me. Are you sure you didn't work ahead?
No,
Fucking good job. I must have fucking presented that pretty well.
yeah,
Note to self, do this all the time.
yes. Falls asleep with the TV on and the radio at like 2 in the morning. Anybody do that?
My brother sleeps with it, he'll go to sleep with the TV on. He likes that, the white noise, to me, it's not white noise enough to hear people talking. If it's on a static channel, oh yeah, that'll put me to sleep. But, you know, like even radio, if I'm even like music that doesn't have words, like classical music. It takes a really slow fucking melody to let me sleep to it, cause otherwise, like there's some classical music that's like, there's no way you're sleeping through it. Like Flight of the Bumblebee.
Yeah.
If y'all don't know what Flight of the Bumblebee is,
I don't know, they played on the drum line.
and we're not talking about the Transformer. You all have heard it before. I guarantee you've heard Flight of the Bumblebee. You may not know its name. It's quiet and it's frantic though,
Trying to fall asleep to that,
right?
stress me out.
Alright, so what do we do here?
First, we wanna divide 18. Of the equations. And since we can't square anything, correct, our radius. Is 6 and 3.
No,
Oh, wait a minute. Yeah, you're
Did you switch the?
right. Center.
it's a little sneaky here, right?
Yeah,
This is not in the form we're used to seeing. So if you work with it as is, you gotta pay attention to what's going on. But I think Lauren's observing that I didn't put my X first. So if I rearrange it, it might be a little bit easier to read. Some stuff is still gonna be harder. Where's my center?
5. 3.
You agree, Lauren, Sarah?
Yeah.
So this value leads to the left and right. And this one leads to the up and down.
Oh, it's still square rooted.
We still gotta take the square root. So the left and right is gonna be square root of 3,
It's like 1.
and the up and down is gonna be the square root of 6. So graphing this would be a pain in the ass to do,
Yes.
and
I think you switched the denominator stuff. Right?
I fucking did.
That's what I was confused about.
I got that shit all wrong, look at that. Thank you. That's square root of 6, that's square root of 3. Oh, rookie move. That's exactly what there we go. Alright. Now let's kick it up a notch to where it's not coming in a nice clean form.
When we square root it, we just round it to the 10ths by the hundreds.
I would round it to tenths to draw it. And really, like. So square root of 3 is 1.7-ish. I don't know what square root of 6 is, but square root of 4 is 2.
2.4.
And square root of 9 is 3. And 6 is closer to 4. So I'm betting it's 2.4-ish.
Yes.
Yeah. I get pretty close. Close enough to graph because. Like if I were to go left to right 2.4. Are you gonna be able to really tell the difference between 2.4 and 2.3? Not unless it's a really good fucking graphing, you got really good eyes. Alright. So let's do the complete the square version. Cause a lot of the completing the square was done on this. Let's kick it up. Let's go full throttle. So to complete the square, we want to put our x's together. And our y's together. That's the first step. Second step, and we've done this a little bit on parabola. But we're gonna factor out the coefficient of the x squared term. And then we're gonna leave ourselves a little gap. And I'm gonna do the same thing with the y squared term. We'll pull out the 9. And we'll leave ourselves some room. Okay, so when we complete the square, we pull that down. We divide it by 2 and we square it. And that's what goes in there. And my parentheses are gonna have an x plus 2 squared with 4 in front. I have added, what have I added to the left side?
4.
Neither. 8's closer.
Oh, yeah.
They multiply together, not add. So 4 times 4 is 16. That's what I technically added on the left. So that's what I'm gonna add on the right. We'll do the same thing here. 4 divided by 2 squared is 4, that's what goes in there. I have added 9 times 4, which is 36, so that's what I'm gonna add on the right side. And the right side ends up being 36. And now since I see the coefficients are different, I know I'm gonna have an ellipse, which means I want the right hand side to equal 1. So we're gonna divide everything by that 36. All right, Keith, you don't respond this time. Lauren or Sarah or James, if you'd like to, I know that you just walked in. What's my center?
-2,
-2, -2. Do you agree, Sarah? Keith, do you agree?
Yes.
I agree. How far left and right will we go? Again, Lauren or Sarah? 3. What about up and down? 2. It's the square roots of those values. Square root of 9 and square root of 4. So that one's actually not too bad to graph. Fuck it, let's do it. Up or down 2, left or right 3. Is that the one we did earlier? Did I just fucking grab the same fucking problem? No, not quite. It was, we had 25 and 4. 9 and 4. It's slightly different center. So. How does it feel? So how's that working for you? Not too bad?
I'm confused, like, when, I think we're done completing the square, sort of like the parabola, you just multiply the C with the.
You multiply the outside by what you put on the inside.
Oh, okay.
Here, you can definitely, before I divide it by 36, you could multiply everything out, then distribute the 4, distribute the 9, and make sure you got to the same starting equation. And we'll do that in the main course. I want to give you guys another one to do, and then if we got time when you guys are done, we'll do the check here. Why don't you guys try 9x squared plus 16y squared plus 90x equals 128y minus 337. Oh, what the hell? What did he do here? So it looks a little off, right? So we got to address that first. Compensate for that first. I don't know yet, Roberto. I'll find out. Oh, wait, we're talking about the last result? Yeah, you probably were. So I'm gonna start off by moving that 128Y over to the left. And I'm gonna sort at the same time a little bit, put the X's together. And then I'm gonna factor out. Space. Is that 8?
Yes.
So complete the square. 5 squared is 25. And I have added 9 times 25, which is 225. And I've added 16 times 16, which I believe is 256.
Yes.
Let's see, those are 12 apart. So 112, 256 minus 112, 144.
Yeah.
So real quick, if we want to make sure we did it right. Check real quick. Before we continue, we got x plus 5 times x plus 5. Plus 16 times y minus 4 times y minus 4 equals 144. That is x squared plus 10x plus 25. This is y squared minus 8y plus 16. I have 9x squared plus 90x plus 225 plus 16y squared minus 128y plus 256 equals 144. I'll subtract the 225, the 256. And I have what we had before we complete the square. So that was a valid complete the square. So back to where we were. We had 9x plus 5 squared plus 16y minus 4 squared equals 144. How do I finish this off?
We divide the outside of the equation, throughout the other side of the equation, I guess.
By what?
By 144.
We do that, I think 9 times 16 is 144. So this should be over 16, and this one on the other one should be over 9. So center, I keep trying to do an H there. Center, left and right, and then up and down. What's my center at?
Would it be -5, 4?
-5, 4. Do you agree, Sarah? Lauren? Keith?
Sure.
Okay. What about left and right? And up and down? Looks good to me. All right, let's take a 10-minute break till the next class starts. You guys are already done with basically learning 12.4. We did the hardest shit there already. I hadn't intended on doing that, but when I